Hello, colleagues. My name is Eugen Zhuk, and we are continue our saga about solid principles. Today, we are going to discuss the last one, letter D, and it's about dependency inversion principle. Before I will start talking about this principle, I would like to remind that during the stream, I will not read any comments, any questions, but please leave them in YouTube, in our community platform. I will aggregate all questions, and we will have a separate session after this one to address all your questions, comments, feedback, and so on. So let's continue with dependency inversion principle. As many other solid principles, it was invented, maybe not invented, but first mentioned by Robert Martin, our well-known Uncle Bob. And it defined in two sentences. So both the sentences now you can see on your screens. So let's read it together. High-level modules should not depend on low-level modules. Both should depend on abstractions. And the second statement, abstractions should not depend on details. Details should depend on abstractions. Pretty the same. I don't know why it's defined in this way, but that's how it was originally articulated in this article with the same name, Dependency Inversion Principle, in 1996. Let's decompose it a little, these statements. So what is high-level modules? High-level modules is software modules where are aggregated all business-related logic, like control flow, like I don't know, everything related to the business logic. It's depend on the particular application. But low-level modules, it's modules where implemented really detailed things like API. And by APIs, I mean particular API, like REST API, databases API. So for example, you use MySQL. So in this case, you should add to your application modules related to this particular database for MySQL, maybe for some particular version of this, and so on. Again, it's about file systems and everything what can contain some particularities. And what is abstractions? Abstraction is interfaces or abstract classes that define contracts for behavior. So when I think about it, I always imagine this diagram. So we have high-level modules, we have low-level modules, and abstractions between them. So high-level modules never communicate to low-level modules directly. Low-level modules have no idea and should not care about where it should be used, plugged, and so on. And everything in the software application should be connected through these abstractions. If you follow all our meetings about Solid, probably you have already seen this. For example, this slide from our second meeting when we discussed open-close principle. And that's the same structure. We have high-level component like financial report generator here, low-level, something with details, and interface between them. And again, the same dependencies. Financial report generator like high-level use this interface, but financial data mapper implements this interface. Here, the same. Report controller use financial report presenter, which use this interface, and some particular presenters implement this interface. Let's go further. This from least cost substitution principle. Again, some billing high-level component, high-level module, some low-level modules with particularities, with realization, and again, we see this interface between them. So another principle, but the diagram almost the same. That's from our last one, interface segregation. That's a little wider than previous, but you see the same idea. Some high-level components like user 1, user 2, user 3 use in their code some interface, but particular class realizes interface. What does it mean for me? For me, it looks like dependency inversion is the key for all other principles. And all other principles can be realized through dependency inversion. That's the slide from Robert Martin's book, Clear Architecture. And let's follow this diagram and try to understand how it should be implemented. So here you see that it's extended a little. So we have high-level application and low-level concrete implementation. This application contains all business logic, which can we imagine. Some particular implementation contains some particularities, like, for example, API. Here you can see that this application depends on this concrete implementation through this service API or service interface. So in code of application, we will never see this complete implementation, but only service. And now we have some kind of problem. So how it should be instantiated? Because most likely this application, encoded everything high level and so on, but we should to call, for example, very, very particular database. So in this case, we have to create an instance of this database. And exactly for this, we have kind of army of creational patterns. And most famous of these abstract factory or factory method doesn't matter for our goals, but let's consider it as some factory. What is factory? Factory, it's a kind of pattern which creates new object without direct instantialization. So application will not create new concrete implementation, but it delegates its creation to the factory. And to be more abstract here, so we know that high-level code should not depend on low-level implementation. Again, in application code, we see only service factory interface. And somewhere in application, for example, in some controller or in some dependency container in case we use dependency inversion, dependency injection pattern, it can be directly initialized. So here on this diagram, we see this, I believe, pink line, and that's kind of border. So that's architecture border between two levels of applications. So here we have abstract part. Here we have very, very concrete part. And now let's see dependency flow. You see that dependency flow, these arrows with open endings, means that implements. So this service implements this interface, this concrete implementation implements this service. So it moves from one direction, from low level to high level. But control flow in the application flow in opposite way. So application use service, use this concrete service, use this particular factory, call it, and so on. So control flow move to opposite way. And we can say it's not opposite, but in inversion way. That's how this principle called dependency inversion. So it means that dependency should be organized in inversed way to control flow in the application. Also from this diagram, we can see again that in our application, we never use any mention of this service factory implementation or concrete implementation of this particular server. In original article, also mentioned that dependency inversion means that in high-level components, in use, insert, import instructions should never appear anything except high-level abstractions. Let's maybe continue with some coding. Again, for people who seen our previous lections, I would say it's not a new slide. We already seen it. I believe we've seen it twice. That's how it can work without dependency inversion. So we have some email service, which you have one send email method, some notification service directly use this email service in this code. So that's a violation because our notification service, which obviously high-level component because it's about notifications contains business rules, use very, very low-level implementation of notification service like email service. That's a violation. How it can be improved? Okay, let me probably a little zoom in. By introducing the abstractions as we did it for at least for open-close principle. It's the same, absolutely the same example. Introduce some kind of abstractions. Now email service should implement this abstraction. Our notification service depends on abstraction, not from on particular implementation. And for us, that means that we can safely add new functionality to our application, and also we can change these particular services absolutely safely. So for example, we can replace our email service with, for example, email service version 2, and our high-level application will not know about this. It will work as it worked previously, without any changes, without any violations, and most likely without errors. First time I implemented this example with factory, just to fully illustrate the Robert Martin's idea. But it was a little bit overcomplicated, and for such example, I believe we don't really need factory, but you can easily replace this installation of email service and SMS service with factory and just assign it to new variables and put to the notification service. Everything will work absolutely the same, but with factory. Obviously, for more complicated applications, for real-life applications, most likely we will need something like abstract factory or factory method or whatever, for example, dependency injection pattern. One important thing. So here you see new words, and I read in some articles another definition of dependency inversion principle. So in these articles was mentioned that dependency inversion deny using new keyword in high-level components. That also can be true, because you see, for example, on this high-level component, and in real application, it will be separate file, and this file will not use the new keyword, but in import instruction, you will have only this notification. Oops, sorry. How to switch it off? Only this notification interface, but not particular implementation. And I have read initial article by Robert Martin, and no, I haven't seen in this article that new it's denied. So we can use new, for example, for very stable dependencies. So for JavaScript and TypeScript, it's not so maybe actual, but for Java, so you obviously can should and have to create new strings, new number, new like primitives, and maybe some objects which already included into the language library and so on. So particularly the same with all languages. So it doesn't mean that you should avoid any details in your application, in your high-level components. That probably means that you should avoid some unstable dependencies. So, for example, in case it's very, very stable library, which included to the language standard, you can use it in your high-level application. You can import it and you can instantiate it directly, because it's almost no chance that it will change and it will bring some problems. Let's okay, that's my example with the factory. Let's skip it. For now, let's continue with React. So yeah, as we know, we on JavaScript works, we love React. So here probably some kind of examples of React component. It's especially without any TypeScript code. It's only pure JavaScript and React. So what we have here, use API service. It's kind of custom hook. So this hook calls some API and, for example, emulate return from the server some list. So return fetch data and how we can use it. We use it like a hook, create fetch data, and use them, send this fetch data in our application. Agree it could be replaced with just call this API service directly without this hook, but let's make it a little bit more complicated and more sophisticated. It's not compatible with dependency inversion because in this case, our items list depends from this particular fetch data method. How it can be improved? Almost the same. This we also create this use use data hook, which use as a parameter some kind of data service. So we create abstractions here, and now you can see that our item list component doesn't know anything about particular implementation. So some data service appeared here as a props and no links for particular implementation. Here we have API service. This API service passed as a parameter, as a prop to our component. So component have no idea about particular implementations. It depends only on high-level abstractions about some kind of data service, which it can be, we don't know. Some maybe things you should avoid using dependency inversion. First of all, it's over abstraction. As I mentioned previously, this principle allows you to use new keywords in your high-level application, but make sure that, and even it allows you to import particularities and low-level dependencies, but make sure that it's well-defined, stable, and so on. But everything what's not so stable. So for me, it's a rule like if we create this service by ourselves, it should be dependent through the abstraction. In case it was implemented, like, for example, part of React API, we can relate it and we can use it directly. But yeah, it also can be changed, like between React 18 and React 19, but who knows. Another, not error, but I think what I hear quite often, and even before this talk, I repeated a few times dependency inversion, because from time to time I can say dependency injection. That's because I first familiarized with dependency injection, and only in probably 2 years I knew that dependency injection, it's a design pattern which implements dependency inversion. So dependency inversion, it's solid principle. Dependency injection, it's design pattern. And yeah, often during the interviews, during the assessment, people confuse with these two words. And ignoring low-level details. That's what I mentioned from the very, very beginning. Not very beginning, but at the beginning of the slide. So yeah, not all dependencies should be avoided, only unstable and what highly chance that they will be changed, replaced, extended, and so on. I believe that's it about dependency inversion. Again, I would like to repeat my thoughts that dependency inversion. It's a key for all solid. In case you understand this principle, in case you will use it, most likely you will automatically use open-close principle. Most likely you will adopt automatically Liskov substitution principle. When you start slice your interfaces to small chunks, so not use huge interfaces, you will also adopt interface segregation principle. And if you will use in your practice these four principles, the most complicated, like single responsibility, will be adopted automatically, because I cannot imagine how you can organize your code according to the file system without it, if you will follow all other four principles. So thank you for being with me for these 5 sessions. I hope you enjoyed it. Thank you all for your comments, your questions, your badges. It's motivate me to continue. And as I promised, we will have one additional session dedicated to Solid, where I will address your questions you put in comments on YouTube platform or on our community platform. Thank you. Have a good weekend. Bye.